Good morning, one and all. Welcome back to the video lecture series for linear integrated circuits. This is Dr. P SREENIVASULU. Today, we are going to discuss about the circuit symbol of op amp, about open loop voltage gate, and inverting amplifier. Now, in the previous session, we discussed about the ideal characteristics of op amp. Now here, if you see the ideal characteristics of op amp, open loop voltage gain infinity, input resistance is infinity, output resistance is 0, and whenever V1 and V2 are equal to 0, then the output is 0 and slew rate is infinity, CMRR is infinity, bandwidth is infinity. These are all our ideal characteristics of op amp. Now, if you see this open loop op amp, you see here, it is the circuit symbol. If you operate, it is in open loop. Open loop means there is no any feedback from output to input. So it is called open loop. Now, if you observe here, V1, V2, and either of the input terminals draws no current, the voltage difference between inverting terminal and non-inverting terminal is 0. And this internal op amp, the equivalent circuit, if you draw the entire internal block diagram of op amp for the ordinary user, so there is no need to analyze everything. But the equivalent circuit of op amp, you must know. Now, if you see, the entire op amp is going to be replaced with a simple equivalent circuit. Here, at the input side, there is a input resistance Ri. So, across this Ri, what is the voltage? That voltage is the Vd, a difference between non-inverting terminal, inverting terminal. Now, you see output side, there is a dependent voltage source. This dependent voltage source is AOL into Vd. Here AOL means OL indicates open loop, A indicates gain. Open loop voltage gain into Vd. This Vd is the input. So this output is depends upon input. So we can call it is dependent voltage source, and it is series with a output resistance. It is simply like a Thevenin's equivalent circuit at the output side. So finally, if you see whatever the current drawn by R0, if we neglect, the output voltage V0 is equal to AOL into Vd. It is we are obtaining from equivalent circuit of op amp. Then, if you want to operate this op amp in open loop mode, just if you observe here, we need to apply two input voltages at two terminals. Now, in this diagram, if you observe in the diagram C, V2 applied at inverting terminal, V1 applied at non-inverting terminal. So, if you see the output, this output is just act as a comparator, because if you see from the formula, V0 is equal to AOL into Vd. Just now we said that this AOL, open loop voltage gain, is infinity for an ideal op amp, And if you consider a practicals 141 IC, it is here, it is around 10 power 6. So it is very high value. So because of this high voltage gain, this op amp is not driven into the linear region. So it is entered into the saturation region. Whenever it is entered into the saturation region, the output is equal to supply voltages. Whether non-inverting terminal voltage is more than the inverting terminal voltage, the output driven into plus VCC, that means plus VSAT. Suppose inverting terminal voltage is greater than non-inverting terminal voltage, the output is minus VSAT, nothing but minus VE. So the output, whether it is plus VSAT or it is minus VSAT, whether it is a plus VSAT or it is minus VSAT. So whether V2 is greater than V1, it is minus VSAT. V1 is greater than V2, it is plus VSAT. It is about the operation of open loop op amp. So the output always, whether it is in plus VSAT or it is in minus VSAT. So it is just act as a comparator. Only it compares the whatever the input terminals present at the inverting and non-inverting terminals. So that is the main drawback of op amp if you operate this op amp in open loop mode. Now, we are saying that it is an amplifier, but it is not behaving like an amplifier. So it is just act as a comparator. So that's why we need to utilize this op amp. So for utilizing the op amp, we need to introduce the feedback here. So if we apply the feedback, again there is a question whether you need to apply a positive feedback or whether you need to apply a negative feedback. There is a two types of feedbacks here. So again, the question, if you apply positive feedback, what happen? You know, in the positive feedback from the amplifier concepts, the gain is again increases. So already because of high gain only, this op amp is enter into the saturation region. So it is just act as a comparator. So again, if you use a positive feedback, again it is act as a comparator. So that's why better you use here a negative feedback. So what is the negative feedback? The output terminal is again connected back to the inverting terminal. The output voltage is again connected back to the inverting terminal. So the part of the output connected back to the input terminal through the RF, through the feedback resistor RF, then it is called negative feedback. It is called negative feedback. So whenever we are connecting the output to the inverting terminal through feedback resistor, we are calling it is negative feedback. Then in the negative feedback, we need to consider two important points here. We need to consider two important points. So the important points are the voltage difference between inverting and non-inverting terminals must be 0. It is 1 point. And another point is either of the input terminals means non-inverting terminal and inverting terminals draws no current. So if these two conditions satisfy, then you can introduce a negative feedback. Then the op amp is not driven into the saturation region. The op amp is now in linear region. Now it is act as an amplifier. So the utility of an op amp is greatly increased if you use the negative feedback. So that is the main advantage here. So whatever the drawback of op amp, that that op amp drawback is overcome by this negative feedback. So then this op amp acts as an amplifier. Okay, are you understand? It is the main point. Next, now we are saying it is an amplifier. We are going to connect. It is an amplifier now. Whether it is act as an amplifier, we are going to test. Now first one is inverting amplifier. Now see first diagram how to connect the inverting amplifier, and then you can see the analysis part. If you observe this circuit diagram, now if you observe here, instead of connecting open loop mode, well, you see there is a feedback resistor between output to input through to the inverting terminal through a feedback resistor RF, and in between input to the inverting terminal there is an RI input resistance. Now this RF feedback resistor, always you choose greater than RI, then only we are going to get the gain, more gain. And the non-inverting terminal is connected to ground. So input is applied to the inverting terminal. So that's why it is called inverting amplifier. Observe this one. Input is, it is an inverting terminal minus, it is a non-inverting terminal plus, it is the output V0. Now this Vi is connected to inverting terminal through this Ri, and this V0 is again connected back to the input through the RF. Okay, it is the concept of feedback. Here again, you need to assume the concept of virtual ground concept. The concept of virtual ground is plays major role here. The virtual ground concept means we know open loop voltage gain is infinity. Open loop voltage gain is infinity. So V0 is equal to AOL into VD. V0 is equal to AOL into VD. So VD is equal to V0 by AOL. So open loop voltage gain is infinity. So V0, it might be some finite voltage will come. So VD is equal to 0. So VD equal to 0 means what here? The voltage difference between non-inverting terminal and inverting terminal. The voltage difference between non-inverting and inverting is equal to 0. It is equal to 0. Now, the voltage difference between non-inverting and inverting is equal to 0. When it is going to be get 0, already the non-inverting terminal is connected to 0. So VD is equal to 0, one of the input terminal is 0, automatically when the condition is satisfied, this other terminal is also equal to 0. So non-inverting voltage between non-inverting and inverting terminals is equal to 0. Definitely the voltage at node A is also the 0. But if you observe here, we are not connecting this node A to 0. But we are imagination. Virtuality means we are imagining it is going to be, this voltage is going to be deemed to be 0 or assumed to be 0. So even if we are not connecting that VA to 0, but we are assuming to 0, that's why it is a virtual ground. The voltage at A is going to be called virtual ground. So meaning is whatever the non-inverting terminal voltage, that is equal to voltage at inverting terminal. That is the point. Whether it is a 5 volts at the non-inverting terminal, we need to assume at inverting terminal is also 5. Then only the difference between these two voltages are 0. So it is the concept. Now, while you are coming for analysis part, there is another important point. Either of the input terminals draws no current. Ideal. This op amp we are analyzing with an ideal op amp. So either of the input terminals draws no current. But if you take a practical op amp, there may be some offset current and some biasing currents are there. It is in the order of nanoamperes. and picoamperes also. It is very less amount of current is drawn, but whenever we are discussing about an ideal op amp, the either of the input terminals draws no current. So there is no any current in between inverting terminal or non-inverting terminal. Now whatever the current we are assuming I1 at the node A, Kirchhoff current law, all the currents entering is equal to sum of currents entering is equal to sum of currents leaving. Now here I1 is entering and IF is leaving. So I1 is equal to IF because the whatever the current drawn by the op amp is 0 here. Now whenever if you write the current I1, so simply it is a Ohm's law. There is a two terminals at the resistor. The voltage difference between the two terminals. So what is the voltage difference? One end it is a VI, other end it is a 0. So VI minus 0 divided by R1 or RI. It is a I1 or II. Now coming for IF, one end it is a 0 potential, other end it is a V0. So IF is equal to 0 minus V0 divided by RF. And then you can equate this term, I1 is equal to I2. It is the idea. Otherwise, you apply nodal analysis at node A. Anything is right. Now, you see here, he has taken from I1. So, I1 is equal to VI by R1. VI by R1 means VI minus other end potential is 0. So, VI by R1. Next, coming for IF. This IF is equal to 0 minus V0 divided by RF. So, V0 is equal to here 0 minus V0. V0 is equal to minus IF into RF. What is the IF? IF is equal to I1. So, finally, the output is going to be right in terms of I1. So, minus I1 into RF. What is the I1? VI by R1. Now, this gain factor is RF by R1. So, always you choose RF is greater than R1, then only we are going to get more gain. And output is in terms of input, and there is a minus sign indicates it inverts the phase. It introduces a 180 degrees phase shift. Suppose if we apply positive, we are going to get negative. If we apply negative, we are going to get positive. It is like a CE amplifier. Now CE amplifier also, it introduces 180 degrees phase shift, but the gain is less in CE amplifier. The gain is more in operational amplifier. That is in our hands. How much gain we require, that gain is going to be selected based on the RF and R1. So we are going to get that gain. So it is one way of analysis. Now, alternatively, suppose if you feel it is a little bit of confusion, simply if you apply here a nodal analysis. So nodal analysis means apply nodal analysis means voltage, this voltage, you assume this voltage VA. Now VA minus VI divided by R1, VA minus V0 divided by RF, and there is no any other current, so equal to 0. And based on the virtual ground concept, we know what is the voltage at node A, 0, because already we assumed that VA is equal to 0. Whenever if you substitute VA is equal to 0, simply we will get that equation. ACL means here closed loop gain. ACL means it is a closed loop case. So closed loop gain is equal to minus RF by R1. So it is a simple inverting amplifier. Okay. Now you see simple problem on this inverting amplifier. Design an amplifier with a gain of minus 10 and input resistance equal to 10 kilo. Okay. The circuit diagram, previously whatever the circuit diagram, again you redraw here. Same figure we need to consider. Then he has given the R1 input resistance. R1 is equal to 10 kilo ohm. And design an amplifier with a gain, a closed loop gain, he has given minus 10. Now, what is the other component we require for designing an amplifier? Already there is an amplifier, 741 IC we are going to take. And R1 he has given closed loop gain also has given. You need to select what is the RF. So simply ACL is equal to minus RF by R1. And then from that equation, if you write RF is equal to minus ACL into R1. So ACL means closed loop gain. It is a minus 10. So minus into minus plus. It is R1 is at 1K. So finally, R1 is a 10K. So finally, we are going to get RF is equal to 10 kilo. So like that, it is with the less number of components, we can design a amplifier. Whatever the gain we require, that gain we are going to be achieved here. Okay. It is about a small problem on amplifier. You want to see another problem at the same figure. R1 is equal to 10K, RF is equal to 100K, and VA is equal to 1 volt. A load of 25 kilo ohms is connected to the output terminal. Calculate I1, V0, IL, and total current I0 into the output pin. Now again, the circuit diagram, again you redraw the same circuit diagram, whatever the inverting amplifier circuit diagram. From that we know I1, input current, that is a V1 by R1. He has given that V1 is a 1 volt. So 1 divided by R1 also he has given it as a 10K. So we are going to get the input current is 0.1 milliamperes. Now gain, closed loop gain, V0 is equal to minus RF by R1 into VI. So RF is given 100 kilo ohm and R1 10 kilo ohm. VI also has given 1 volt. So we will get the output voltage. Kilo ohm gets cancelled. 0 gets cancelled. We will get 10 volts output voltage. For the given input voltage 1 volt, we are going to get output voltage 10. Next, IL, load current. So load current also from the diagram, if you see, observe this one. This is output voltage, it is a ground potential. So if you write IL here, V0 by RL. So IL is equal to V0 by RL. It is equal to 10 volt by divided by RL is given where it is 25 kilo ohms. So you will get 0.4 milliamperes. Now, yes, asked that another one is the total current I0 into the output pin. So total current I0 into the output pin means it is the output current I0. This current is leaving and this current is entering. Whatever this current, it is coming from here, the same current is coming, is entering. So I0 is equal to IL plus I1. So we write this one. I0 is equal to I1 plus IL. So I1 already we calculated 0.1 milliampere. And I2, IL, just it is, you have calculated 0.4 milliamperes. Finally, it is 0.5 milliamperes. It is about a small problem on inverting amplifier. I hope you understand. Now again, the simple concept here, the hint I am going to give again. Entire concept is depends upon virtual ground concept. The virtual ground concept means whenever we are introducing a negative feedback, we need to remember either of the input terminals draws no current. The voltage difference between non-inverting terminal and inverting terminal must be 0. So it is the basic idea. Why you are assuming it is 0? Because V0 is equal to AOL into VD. So open loop voltage gain, we are assuming this op amp is ideal op amp. So open loop voltage gain is infinity. So VD is equal to V0 by AOL. So that's why VD is equal to 0. So VD is equal to 0 means what is this concept? Already one terminal is it is ground potential. So to make this VD is equal to 0, automatically voltage at VA is also be 0. Suppose blindly you remember whatever the voltage present at non-inverting terminal, that is going to be present at the inverting terminal. That is the overall point. Here it is 0, that is also we are assuming 0. Suppose it is 3, we are going to assume that is 3. So it is the final point of virtual ground concept. If you learn the, if you get the idea about virtual ground concept, op amp analyzation is over. Entire op amp analyzation, any circuit is entirely depends upon this virtual ground concept only. Today I am going to stop this. We'll see in the next class remaining application, non-inverting amplifier, all these things.